All right, so 4.2 linear relationships. All right, so now in this lesson, what we're going to be doing is we're actually just going to be throwing graphs into the mix now too, like what graphs of linear equations look like. So for example, if we look at this data over here, right, like stuff like we've been doing, right? So if we had like number of floors, and then that related to the height of the building in meters, then we can see, okay, the number of floors are going up by a constant amount, right? 1, 2, 3, 4. And then the height of the building was, okay, what's that going up by? That's going up by 3, it looks like, right? So it's going up by 3. So I could say that the height of this building is equal to 3 times the height of the floor, or 3 times the number of floors. And then I just need my like plus or minus part on the end there, right? Do you remember how we found that from last time? So, yeah, maybe you guys don't want to talk about say it out loud, but the way we can find that is we can start throwing some numbers in too. That was one way, right? Where I could say, okay, if I threw in 2 for my f here, then I want to get out 8, right? So I could say, okay, 3 times, if I said h is equal to 3 times 2, right? Well, that's equal to 6. But I want it to be 8. So really, this has to be plus 2. Right? So then the actual equation is 3x plus 2, or 3f in this case, not x. Okay? If you remember, the other way we did it is, let's say if we went back to 0, right? So if the number of floors was 0, then what would this be? So if the number of floors was 0, then this would go back to, well, if they're going up by 3 every time, we go down by 3, so that would be 2. So again, it'd be plus 2. Okay, so both those things work. Now, what we can do here is we can make an actual graph of this situation, right? So the way this works, right? So the number of floors, oh, I was trying to zoom in there. The number of floors would be like our x values, right? So that's these. These are going across our, x-axis. They're going this way. So this is where it's 1, 2, 3, 4. And then the height of the building, that's like our y's, right? That's like these ones. So if we just actually plot this data, we can see that, okay, when we have one number of floors is 1, and we plot that, this should be at 5. 5 would be between 4 and 6. So that'd be our first point. And then if we went to 2, well, that should be at 8, right? So if we were at 2, then we'd be up at 8. If it was 3, then we'd be up at 11. And if it's at 4, then it'd be up at 14, right? 4 and 14. Do you guys see how this actually ends up making a line, right? This is where the word linear equations and linear relations comes from, right? Is that if you were ever at graphing and you end up making a line out of it, then it's a linear relation, okay? All right, so the other kind of neat thing I want you to see here is what happens if we go all the way back, right? So I was telling you guys, oh, that went off. So if this was a line and a straighter line, I'm having difficulties right now. That should be straight. You would see, like I said, if the number of floors was 0, and then we went backwards here and we said this was 2, okay, well what that means is if the number of floors here was 0, then we would be at 2. So this will actually always be the case when we have this equation, that this 2 is always going to be where we start, right? That's going to be like our starting position when we get going. Okay, how you guys doing with that? Recording back on. All right, so yeah, let's move down here now. So now, when we can have all kinds of different graphs, right? And as you guys go through grade 10, 11, and 12, we're actually going to go through each of these types of graphs, right? We're going to go through this one, and oh, lost my pen there, and like these different types. For now, though, where we're starting is just with the line, right? This is a linear graph. So if it does like a curve or anything like that, that's not a linear relation. Same with this. Or, you get some kind of weird V type of a shape like that, right? So Yeah, so if a question asks you like, is this linear, you guys should be thinking, does it make a line? Like all the data. Okay, so then if we're given an equation with two variables, like this one, right? We can ask ourselves, is this thing going to be linear? Just like let's say this is all we knew was this, right? Well, let's actually make a table of data, right? So I can put whatever numbers I want in for x, right? These are all my x values. So what that means is that I can replace this, right, x, with -2, -1, 0, 1, or 2. And actually, it didn't have to be these either, right? I could have made it like -1,000,000 if I wanted to, right? You can make any point you want, and you get some other point out for y. Okay, but typically it's kind of nice to start a little bit into the negative and then go a little bit into the positive in the end there. It's also kind of nice to go up by 1 if you can for your x's. But yeah, you could actually put any numbers you like in, right? This is like our input, and this will be like our output. Okay, so I'll just show you what that means. So like, let's say that for our first one, that -2, right? What I'm going to do is I'm going to put that in. So that would be y is equal to 5. Here, I'm just going to write it one time above. So it'd be 5 minus x. But now I'm going to just throw in -2 for x and see what we get out. Okay, so this would be y is equal to 5 and then minus, and then careful with this because it's 5 minus, and then I'm putting in -2. So I'm going to put it in brackets, right? It's going to be minus -2. Do you guys see that I put -2 in for the x there? And how that changes things, right? That's the same thing as y is equal to 5 and then minus a negative. That's the same thing as just plus 2. So y is equal to 7. Is equal to 7. Okay? So that's the way this is written here. It's written a little bit funny. It says 7 is equal to this, but it's the same thing, right? 5 minus -2 is equal to 7. Okay, so what that means is that there is a point on my graph, right? So if I was graphing this thing, which we will down below in a second, when x is -2, so over here, right? This would be like, here, so this would be like, -1, -2 for my x's, and these are my y's. So when x is -2, y would be all the way up here at 7. Does that kind of make sense? And there'd be a point here at -2, 7. And then we can do the same for these, right? So when x is -1, y is 6. When x is 0, y is 5. When x is 1, y is 4. Do you guys think this is linear or not based on the graph?
I'm seeing it, I think it's non-linear.
Okay. It actually does end up being linear. I'm just kind of looking at these numbers right now. Like, these are what they turn out to be. And even though they go down, like in the last lesson, usually they were going up, right? This time they're going down by 1 every time. But that does mean it's linear, right? It changes by the same amount every time. So this thing is linear. So let's graph it. Let's actually like graph this thing and see what it looks like when we graph it. So, you know what? I'm gonna let you guys graph it. So you have this little tool right there. So I'm gonna open this up so that you can. It should show up on your screen there. See if you graph this thing. So you have a dot right now, so you can make a dot wherever you like, right? That's not the correct answers. But I'd like you to plot this data, right? So when x is -2, y is 7. I'll help you out with the first one, right? So I'm going to go over to the left, right, to -2, and then up 7. So my first point would be right there. So then you guys are going to do -1, right? So when x is -1, y should be 6. So plot that point. Where is that at? Okay, so I'm going to go through this one too quickly. So some of you guys were saying that, yeah, once you kind of see the pattern, then you can just go from there. That's exactly right. You really only need like 3 points to get this thing going, and then you know where it's headed, right? So if I do the second one, that's going to be at -1, right? So when x is -1, then y is 6. So when x is -1, y is 6 would be right there. Okay? And then when x is 0, right? So 0 is right there for my x, right? These are my x's. and then y is 5. Looks like I got a line going, doesn't it? I don't even really need to like look at these other ones, do I? Because I'm like, okay, I got a line going. The next one's there, and the next one's there. And just, I can even double check though, right? When x is 2, y is 3. Yep, that's exactly what it is. So I do have my linear relation going. Okay, so let's do it again. So this time though, they've given us like our x values aren't so nice, right? Do you remember last time our x values went up by 1 every time? We started at -2, -1, 0. This one they're not evenly spaced out, but that doesn't mean it's not a linear relation. It still could be, right? So let's try this one out. So you know what? I'll give you guys a hand with the first one. Just make sure that we're inputting this right. So for -4, this would be here. I'm just gonna write it out one more time. Y is equal to -x plus 4, and this -4. This means I'm gonna put -4 in place of x, right? That's my input. I'm inputting 4. I want to see what I get out for y. Okay, so I'm going to write this out as y is equal to, and now careful on this because it's minus, and now I'm going to input -4, and then plus 4. Right? What does this actually become? Anyone want to tell me?
0. A positive?
Yeah, it becomes a positive. And so whoever said 0, I think you were one step ahead of me even. Yeah, that will become a positive, right? When you minus a negative, that's going to be the same thing as just positive 4, right? Actually, sorry, it won't become 0. My bad. That'll become 4, and then plus 4. So this should be 8, right? So y is equal to 8. So what that means is when I input 4, or -4, I get out 8. Okay, so that would be your first one. When you guys do it here in a second, 8 would be your first number. I'm going to let you guys do the other ones though. So I'm just going to pause the video and let you guys give it a try. When you're done doing this, then you can plot the data. Right? So then I'm going to let you guys use your graph here and then see if you can plot it. Alright, so if you're watching the recording, that's what your numbers should have been there. Alright, so let's plot this now. So -4, so I'll go over negative to -4. And then up to 8. So my first point would be right there. And then the way this graphing tool works is I just need to make one other point, and then it'll connect those, right? So I could either use 0, 4 or 1, 3. They should both work, right? I'll just use 0, 4 though. So when x is 0, y is 4. So that'd be my second point there, right? But I can also see if I kept on going down, when x is 1, right? When x is 1, y is 3. That's also true, right? So there you go. So that would be the right answer. So yeah, if you guys got that one, pat yourself in the back. Okay, now, no table. You guys just need to make the line. So you can use any point you like when you're making this thing. You guys could throw 0 in for that. You could throw 1 in for that. You could throw any... You really could. Well, actually, it would have to be between 15 and -15, but... I think it'd be easier if you threw in maybe 0 and 1, right? Those are typically kind of easier numbers. So can you guys graph this? See what you can do, right? You're going to throw in two numbers because you need 2 points to make this line. Okay, so I'm going to pause it there, and then we'll see how you guys do. If you would like this to look like the table, feel free. You could write a table out like this, right? X and Y, and then let's do the point 0 and 1. Okay, and we're just looking for those y's.
You didn't open student input.
Oh, sorry guys, I forgot to turn the recording again. So if you're watching the recording, then here's my steps. I found when x is 0, y is -2. When x is 1, y is -8. Okay? So, alright, so now we'll plot these. So when x is 0, that's right here, right? When, like, x is 0. And then our y is -2. So right there, that's our first point. Okay? Now we got to find my second one. So we'll use 1, right? So when x is 1, it said y is all the way down here at -8. So there you go. So that should be it. And now it says, is the point -1, 10 on the graph? What does that mean? So the point -1, 10, that means x would be -1 and y would be 10. Right? That's my x and that's my y. So let's see. So when x was -1, Well, that's not right because we already said it was -8, didn't we? That point would be here. That'd be below the graph, right? So that's not on the graph. So that'd be no. All right, so you guys should be able to see how you did there. Uh-oh. did we get any of them right? All right, so hopefully you guys kind of saw what I did there to practice a little bit. All right, next one. Okay, let's do it again. I'm going to let you guys choose now. The way this one works is you get to choose whatever number you like for x. Okay, so you could choose 1, 0, a million, if you want, and then figure out what the y value is with that. Okay, so again, I'm gonna well, you know what? Here, I'll help you with the first one. Just kind of get you rolling. So let's say it was y is equal to, so -2x minus 4, and now I get to choose what I want for x. So you know what? I'll choose. I'll make this -1, 0, and 1. Sure. This could have been 10. You could do anything you like, right? But those are easy numbers sometimes, right? So, all right. So let's go y is equal to. So for -1, that would be y is equal to -2. And then instead of an x, I'm going to put in -1, right? So I like to put it in brackets. So -1 like that. Just to show myself or remind myself that I'm putting -1 in for x. Okay? And then -4. All right, this part here, -2 times -1. Negative times a negative gives me a positive, right? So that would just be 2. And then -4. So then y is equal to 2 minus 4 is -2. All right, so then in that case, this would, if I'm using -1, then this would be -2 for my y. So I'll let you guys choose whatever you want for your x values and then fill in these two. And then again, use the graphing tool to make a line. Okay, so I'll pause it there and I'll see if you guys can get that one. Okay, so we did the first one where we put in -1. So now I'm going to put in 0. Okay, so now this would be y is equal to -2, right? But now instead of an x, I'm putting in 0. -4. So we've got y is equal to, and then -2 times 0, right? That cancels. 0 is always nice. So then that's just -4. So -4. Okay, so that would be -4. And then last one would be 1, right? So instead, so say y is equal to -2, and instead of an x, I'm putting in a 1. -4. So now -2 times 1 is just -2, and then -4. And just be careful on this one, because -2 minus 4 is -6, right? You got more negative there. Okay, so then that would be -6. Now, I can already tell that this thing is linear, right? Because I'm going up by the same amount every time, right? These ones are the same amount every time, and those are the same amount every time. Then that's definitely going to be linear. But let's graph it now. So we graph this thing. Our first point I'll make at -1, -2. So -1, -2. So there's my first point. And then I'll make my second point for 1, -6. Okay, so 1 and -6. And there you go. You can also see that at 0, right, I was at -4. I could have also made my point right there if I wanted to as well. Okay, but that should be good enough. So let's see if we're right. Yay! So now let's look at some examples of what makes something a linear function and not a linear function. So we need to be able to tell this from the graph, and we need to be able to tell it from a table of data as well, right? So let's look through these. This one's multiple selection, right? So there might be more than one that is a linear function. So what we want to have when we're looking at these is, well, before I was telling you that these had to go up by the same amount every time. But that's only really true if these are going up by the same amount every time, right? Like that your input values are also going up by the same amount every time. Okay, so if they are, so I'm going up by 5 every time on this side. So up by 5, and up by 5. And this side, okay, well, what's this side doing? Well, starting at 7 and then down to -3, that one went down by 10, right? And then -10 down to there, that would be down another 10. And then down another 10, so -10. So yeah, this thing would be a linear function, right? It's the same on both sides. All right, so that one is. So good. Next one. So let's see. So now we've got this one's going up by 5 every time. So up by 5, up by 5, up by 5. This one starts at -5 and goes to 15. So that one's going up by 10. Okay. Sorry, not up by 10, up by 20. Okay. And then up by 20. And then up by 20. So that one also is. So good to go. Next one. So now we've got this one's going up by 5, and then by 10, and then by 5 again. Okay? That doesn't necessarily mean that it's not going to work, because, well, let's fill this in, right, just for a second. I think this might kind of help. So if I'm going to make my own table on here. So this is D and this is K. All right, so this is 5 and 11, and then this was 10 and 26, and then this was, I'm going to fill in a spot for 15 and 56, and then 20, or sorry, no, 15, and we don't know what that is. And then 20 and 56, and then 25 and 71. Okay. So then this one was going up by, well, 26, 26 minus 11, right? So this one's going up by 15 every time. And let's just make sure, like, if this one's going up by 15 every time, we're probably pretty good, because this one was going up by 5, and this was going up by 5. So 56 minus, or sorry, 71 minus 56 to figure out what that's going up by. All right, so this is going up by 15 as well. So it actually seems pretty good, right? Because, well, if this one went up again by 15, so 26 plus 15 would be 41, and then 41 plus 15 would get me to 56. So that one's a little bit tougher. So yeah, that one, this is probably a little bit difficult, right? And it's because they didn't show us that 15 in the middle, and we had to kind of fill that in. But that one would too be linear. Okay. And then this one, I can tell right away that this one doesn't, right? So my x's are going up by 5 every time, right? But look at my h's, or my y's, right? Whatever you want to call it here, my output. This goes up, 72, and then it really goes up, and then it really goes up. This is actually going to be what's called exponential growth. You don't need to know that, but this is definitely not going up by the same amount every time, right? Okay, so that one would not be. All right, so now let's go to the next one here. Okay, so now same type of situation, right? We're just kind of looking at them in different ways. So if we're looking at linear relations, right? Have you guys noticed all the ones we've been doing so far were in this form? They had like y is equal to, and then there was like some number like 3x plus 1, or y is equal to -4 plus x, right? Did you guys see what was happening there? That it was always a y and then just an x, right? Like not x to the power of 2, not x to the power of 3, not dividing by x or square root of x or anything like that. So it actually won't be this one, right? Our linear relations are always just going to have just an x in it, right? It'll be y is equal to a bunch of stuff and then x. Okay, so if they have x squared, then that is not going to make a line. That one would actually do something like this. It would make like a parabola. And we're going to learn about that in grade 11. Okay, let's look at this one. So our x's are going up by 1 every time. Okay, and our y's are going up by 1 every time. So this one is definitely linear. Okay, this one, our x's are going up by 1 every time, so that's good. And our y's look like they're going up by, well, okay, this is from -8 to 3, that's 5. And then from -3 to 0, that's 3. Okay, I know right away that this is not linear, right? They're not going up by a constant amount, right? So this one is not. These ones, okay, the temperature rose at a constant rate of 2 degrees per hour from 8 a.m. until noon. So if it's going up by a constant amount, right, then that will be linear as well. Okay, so that'll be, let's say that this was a graph, just to kind of give you an idea, and this was time across the bottom, and we started at like 8 a.m., and this was at noon. So something like that or whatever. Then if it's going up by 2 degrees per hour, that just means that it was going up by, like, if this is my temperature, then whatever the temperature was here, let's say it was like 30 degrees, then the next one at 9 o'clock, then that thing was up at 32, and then 34, and then 36, and then 38, right? So again, we would end up having a straight line. You can also just tell that from the wording of this when it says a constant rate of 2 degrees. Okay. Now these graphing ones are actually probably the easiest, right? Because what makes something a linear equation or a linear function? Well, it's a line, right? Does it make a line or doesn't it make a line? And that is not a line, right? So that would actually be something with an x to the 3, and the exponent would do something like that. But again, that'll be a grade 12 thing. So, okay, does this one? Oh, right here. What about this? So, y is equal to 2x plus 1. Well, that's exactly the form we've been dealing with, right? Where we got an x, and we got a y. So, yep, good. And then this one, that makes a line. So, yep, that's good. And then for here, no, we don't want the x in the denominator, right? So this is gonna, yeah, this will make a weird looking graph for sure. So not that one. It has to be up in the numerator. And then the last one says the parachuter fell at an increasing rate from the elevation of 5,000 feet to 3,000 feet. So an increasing rate means that this thing would be, well, increasing over time. That means that it would actually look like this. It'd be going up over time, right? So we want that constant rate, right? Linear functions go up at a constant rate. So that one's not. Phew. All right. How are you guys doing with that one? So then just quickly, guys, I'm just going to look at these ones too and just show you the kinds that would and would not be linear. So again, this one would be, and the reason for it is that we've got a y and an x, right? And it's just still x to the power of 1, right? Even though we've got like a fraction out front, that's fine, right? Just we got a y and we got an x. This one, again, the x is in the denominator, so that's no. So that's no. This one, yeah, even though it's rearranged a little funny and we got brackets there, we still only have an x and a y, so that one's good. You could, I'll show you later that we can like distribute that. You won't know what I'm talking about yet, but yeah, that one would be good. Okay, this one, x squared and y squared, nope, that's a no-go. That's actually the equation for a circle. That, yeah, so that's not going to be a line, so no. This one, yeah, that one actually is, right? You got just an x and a y, right? It's rearranged, right? I could do some algebra though, and I could end up making that y is equal to something like 3x plus 4, right? Just doing a little algebra, I can change that. So yeah, so that one's good. This one's a little bit tricky, right? You can't have two x's going on. And the reason for it is after you multiply these things all out, this would end up being like an x squared. Okay, and I know we haven't really done that yet, but just trust me on that. So you can't have two x's multiplied by each other, like in that situation. So that'd be a no-go. And then x to the 3, nope, has to be just x. You also can't take the square root of x's. That doesn't work. You can't have that to make a line. And then this one, yep, that one's good, right? You can just an x and a y, right? So that one is still good.